Okay, students, today our learning objective is to apply triangle sum properties. But before we do that, we're going to have to go over some review topics. First of all, let's start with triangle. How do we define a triangle? A triangle is a polygon with three sides, and as you know, there's several different ways that we can draw a picture for a triangle. But normally when we think of a triangle, we think of the one where all the sides are equal. But you can draw whatever triangle you want. The second one, interior angles. Interior angles are when you take a polygon like this one, a triangle, and you extend the sides of the triangle. The interior angles are simply the original ones, the ones inside, not the ones that we just created. So that angle plus this one and this one, these are all interior angles. Exterior, on the other hand, same conditions, we have extended all the sides. It is the angle that forms a linear pair with the interior angle. So here, if this is my interior angle, the exterior angle would be this one. Or it could be this one over here. And you know that it doesn't matter which one it is because these are vertical angles and they're congruent anyway. For this interior angle down here, this would be the exterior angle. Again, this one could be as well. For this angle over here, it could be this one, or it could be this one here. Okay, so exterior angles are the ones that are in blue. Interior angles are the ones that are in yellow. A corollary to a theorem is a statement that we can prove using the original theorem that was mentioned. There's not a picture to draw for this one. Okay, so now let's continue our review. Like I said before, when we draw a triangle, there are several different ways to draw a triangle. Well, there's several different ways to classify a triangle. We can classify a triangle by sides, or we can classify triangles by angles. If we classify it by its sides, scalene, it's going to either have 0 sides that are congruent. See how these are all different. This is 1, this is 2, this would be 3. They're all different. We call that scalene. It's a scalene triangle. When we have a triangle with 2 sides congruent, these 2 sides are the same, but this one is different, we call that one 2 sides congruent, so it's isosceles. And as you already learned this year, when we have sides that are all the same, we have 3 sides congruent, we call it equilateral. Okay, now classifying by angles. Here, if we have all of the angles inside of it, or all of them, are acute angles, we call it an acute triangle. If we have one of the angles, one right angle, then it is a right triangle. If we have one obtuse angle, just one obtuse, that would be an obtuse triangle. And here, if all 3 of these angles were the same, all 3 congruent angles, we call that equilateral. So here, I'm going to show you that this one, let's see, all of these could be different, and all of these could be different, but all of these would be the same. Okay, so on page 2, here's our new information. Our new information, we have 3 theorems. This first one you will recognize. It's the triangle sum theorem. In algebra, we learned that the angles, all 3 angles of a triangle, add up to be 180 degrees. So the sum of the measures of the interior angles of a triangle is, the sum is 180 degrees. That just means that angle A plus angle B plus angle C equals 180 degrees. The exterior angle theorem is the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent and non-adjacent, I'm going to highlight in orange. Non-adjacent, that means that the two that are not next to it. Here is the exterior angle here. These are the ones inside. So those are the interior. So two non-adjacent interior angles. So this would be right here. This one would be the adjacent angle. ABC is adjacent to angle 1. So that's not the one I'm talking about. The two non-adjacent are the ones that are remote, the two remote interior. They are away from. So the measure of angle 1, what this is saying is the measure of angle 1 is equal to the measure of angle BAC plus the measure of angle ACB. ACB is this angle here. All right, the corollary. Here's your first corollary of the year. Corollary to the triangle sum theorem. If you have a right triangle, then you know that the acute angles of the right triangle are complementary. Now, that's easy to prove because you know that all of these angles add up to be 180 because that's what the triangle sum theorem tells us. If this much of it is 90, then the two leftover angles have to add up to be 90. So here, we're going to give it a name. We're going to call this the CAT triangle, C-A-T. And what this is trying to tell us is that the measure of angle CAT, which is this angle here, C-A-T, that's this angle here, measure of angle CAT, plus the measure of angle ATC, and ATC is going to be this one here, ATC. Those two add up to be 90 degrees. All right, let's do some examples that you're going to find on your practice workbook. Here's the first one. The first one says, classify the triangles by its angles and sides. So in other words, they are asking us to look at this triangle that's in the graph, and they're asking us to give it one of these three names, either a scalene, isosceles, or equilateral, and then also by angles. Call it either acute, right, obtuse, or equal angular. So what we have to do is figure out what kind of sides do I have. All right, so here I'm going to start by identifying my points. I'm going to call this one point A, this one's going to be point B, and this one's going to be point C. A, I know, is located at 0, 2. B is located at 4, 5. C is located at 5, 2. So now I can use the distance formula. I'm going to do this one first here, AC, because it is a horizontal. And remember, when we have sides that are horizontal or vertical, all we have to do to find the length is to count the number of spaces. So here, this is going to be 1, 2, 3, 4, 5. So I know that AC is 5 units long. The other two are harder, but not that much harder. You just use the distance formula. AB is equal to the square root of, And remember, A and B, those are these 2 points here, you have to subtract the x's, and then you have to subtract the y's. So I'm going to subtract the b from the a, 4 minus 0 squared, plus b minus a, that's going to be 5 minus 2 squared. Simplifying this, I get 4 squared plus 3 squared. I know that 4 squared is 16, and I know that 3 squared is 9. 16 plus 9, that's 25, and the square root of 25 is 5. So here I know that AC is 5 units, and I know that AB is also 5 units. So now I have to find BC. So I'm going to do that over here, BC. Now, I have this side and this side already congruent. If this side turns out to be 5 units, then we know that it's equilateral. If it turns out to be different, then we know that it's only 2 sides. And remember, 2 sides was called isosceles. Okay, so here, BC, I'm going to subtract C from B, so that's going to be 5 minus 4 squared plus C minus B, that's 2 minus 5 squared. This pair of parentheses gives me 1 squared plus this set of parentheses gives me negative 3, so that's negative 3 squared. Okay, that's going to be 1 plus negative 3 times negative 3 is positive 9, so that's going to be 9. This is going to give me 10, and I'm going to leave it that way. Now, I do need to know which one is the bigger side eventually, so you can go ahead and plug it into your calculator, but you know that this is the square root of 10 units. You want to use it in this form for the next test that we're going to do. And when you plug this into your calculator, you're going to get 3.16 approximately. And I'm going to put this in a little cloud so you know that this is not the answer, this one is. Okay, so looking at this, since this turned out to be different, I know that this does not, it's not equal to the other two. So I know that I have, first of all, an isosceles triangle. Okay, now, to do the next one, I want to remind you of a previous set of notes. So we're going to write down some additional information here. It's called the triangle test. I'm going to write it down here so I don't have to go back to my previous notes and try to find it. So the triangle test, remember, is you're kind of using Pythagorean theorem, but you're using it backwards, and you have to set it up this way, otherwise it's incorrect and it'll be backwards, it'll give you the wrong answer. If C squared equals A squared plus B squared, then we know that triangle ABC is a right triangle. However, if C squared, notice how C is on the left, is greater than A squared plus B squared, then we know that triangle ABC is greater than, that means obtuse, is an obtuse triangle. And finally, if C squared is less than A squared plus B squared, then we know that triangle ABC is an acute triangle. And then if it's none of those, then it's going to end up being, because we have acute, right, obtuse, and equal angular. So if it's none of these, this one will tell me if it's these three. But if it's not these three, then you know that it's a possibility that it's this one. Okay, so here I'm going to apply the triangle test. So C, remember, is always the largest side. since this one is almost 3.616 units, and these are both 5, then either this one or this one is going to be my longest side. So right off the bat, you know that it's not going to be right because you don't have a longest side. All right, so here I'm going to put c squared, big giant circle, and then I'm going to put a squared plus b squared. So here I'm going to put the 5 squared, big giant circle, then I'm going to put 5 squared plus square root of 10 squared. Running out of room, so I'm going to put it over here. That's going to be 25, big giant circle, and that's going to equal 25 plus, and remember that the square root and the square, they undo each other, so that's going to equal 10. So here, cleaning it up, 25, big giant circle, 35. Now you've seen this all the way back in elementary school when you're evaluating two numbers and you're trying to figure out which one is greater or less than or equal. These two are definitely not equal, and we know that Jaws eats the larger number, so we know that it is less than. So remember, when it's less than, then it's going to be an acute triangle. So we are done by calling it an isosceles acute triangle. You can also call it an acute isosceles triangle if you want. Okay, the next example is talking about interior and exterior angles. They want you to find the measure of JKM. Remember, JKM is what we're looking for, not X. JKM is this angle out here, JKM. Okay, now up here, we are told that the exterior angle is going to equal the two remote interior angles added together. So this outside angle, 2x minus 5, is going to equal the two remote interiors added together, 70 plus x. Subtract x from both sides. I get x minus 5 equaling 70. Now add 5 to both sides. X equals 75. And most people just draw a box around that and they stop right there. But that's not where you want to stop. Remember, they asked for the measure of JKM. So you have to take that and plug it back in. 2 times 75 minus 5. So your answer is the measure of angle JKM will equal, that's 150, take away 5, 145, and remember to put your degree mark, 145 degrees. Okay, almost done. Move it down so you can see it. Okay, almost done. On this last one, this one they want us to find x. And this one, they gave me all interior angles, so we're using the triangle sum theorem. We say that this one plus this one plus this one is going to equal 180. So x plus 3x plus 60, that equals 180. That's going to give me 4x plus 60 equals 180 when I combine like terms. Now I'm going to subtract 60 from both sides. That's going to be 4x equals 120. Divide by 4 on both sides, and you get x equals 30. And I can stop there and not plug it back in anywhere because they only asked for x. Alright students, that's it for today's notes 4.1.